7.2 similar polygons. The similar polygons have the same shape but not necessarily the same size. So think of the dilations that we did where you can enlarge a figure or you can reduce a figure. Remember that symbol means congruent. We've done that and talked about that before. When we say similar, there's a symbol for that as well, and that's the symbol for similar. So it looks a lot like congruent, but it does not have the two equal signs, or the equal sign underneath. So we have what's called a similarity statement. Just like we would have a congruent statement when we name two polygons are congruent, we write a statement that names two polygons are similar. So to name two polygons similar, we have to remember that the order matters. So there's a certain order you have to write the names of both polygons in to have a correct similarity statement. So we'll talk about that and see what that looks like here. Okay. So this, for example, is a similarity statement. I've named two triangles, so those are two types of polygons, and I put that similarity symbol in between. So I'm saying triangle ABC is similar to triangle XYZ. We've seen this before with congruence. When I had two congruent polygons, we did the same thing, except that we put a congruent symbol here. So when I say order matters, it's very much like the congruent statements we did, where whatever angle is here at point A and whatever angle here is here at point X, those would be the two congruent angles. So these are the matching angles. B and Y would be the matching angles, C and Z would be the matching angles. And in geometry, when we say matching, what we mean are corresponding. They're the corresponding angles that as we trace around our triangles, it goes in that same order. So here's an example of the way we can write that, and what these triangles look like here. So here's our two similar triangles, triangle ABC and triangle XYZ. So similar polygons have corresponding angles congruent, just like congruent polygons do, but they're different sizes. So the triangles themselves, or whatever polygon you have, are not actually congruent, but the angles are. So we can see here in our drawing, A and X match up, B and Y match up, C and Z match up. Just like in our statement here, A and X are in the first locations. So angle A and angle X, those are two congruent angles. B and Y are in matching locations, so angle B and angle Y are two congruent angles. And then C and Z are in matching locations, so angle C and angle Z are congruent angles. So similar polygons have congruent angles. They look like dilations where one is an enlargement of the other or one is a reduction of the other. Same shape, not same size. Similar polygons have corresponding angles congruent, and the next piece, they have proportional sides. So we just worked on solving proportions, and what we're going to learn is how to set up a proportion using those different sides, so proportional sides. Okay, so our corresponding sides are proportional. So what we do is we can list all of the sides of our first triangle, so that AB, BC, and AC. Here we have our three different sides. And if I go back and I look at my first little named triangle here, I see these are my angles A, B, and C. So I have a segment AB, I have a segment BC, and I have a segment AC. Those are my three different segments. So we know that a proportion looks like two fractions that are equal to each other, or another way of saying that is two ratios that are equal to each other. So you match up and say, what's the corresponding side to AB in the other triangle? What's the corresponding side to BC in the other triangle? And the corresponding side to AC in the other triangle? And you write them as equivalent fractions. That's what our proportion is going to look like. So I can either look at the similarity statement here, and I see AB is a segment that's written first. So I'll go to the other one and I look at what's written first, XY. So XY is the corresponding side to AB. I can also look on my figure and I see AB connects a single tick mark angle to a double tick mark angle, and XY does the same thing, single tick mark to double tick mark. So I can see visually those two match up as well as seeing it in my similarity statement. Then for BC, those are written second, so BC should match with should match with YZ. So here we have BC and YZ. And if I go back, I see BC is between the double and the triple tick mark angles. YZ is between the double and triple tick mark angles, so those two match up as well. Then last we have segment A to C. That matches with segment X to Z. So AC, single mark to triple mark, X to Z, single mark to triple mark. That right here. So those are all of our proportional sides. So if I knew what some of these numbers were, I could write these numbers in and I could have a proportion. Now we haven't solved a proportion that's had 3 parts, we've only solved a proportion that has had 2 parts. But you can look at just these two and have this proportion to work out. You can look at just these two and have that proportion to work out. Or you can look at just those two and have that proportion to work out. And that's what we're going to do, is we're going to set some proportions up using some numbers for these sides, and then we're going to solve the way that we had reviewed solving proportions. So I've now gone and I've drawn in some side lengths for us. We have 2, 3, and 4, 6, 9, and 12. And we want to show that these sides are proportional. So the length of segment AB is 2 units long, so I'm going to replace that. The length of segment XY is 6 units long. The length of segment BC is 3. The length of segment YZ is 9. The length of segment AC is 4. And the length of segment XZ is 12. Now, if these are proportional, it means all of these are equal and should be the same amount. It means we should be able to take our calculator, simplify each of these fractions, and they should be the same or equivalent. So we have 2 over 6. This is that decimal. Math, I want a reduced fraction, and I get 1/3. So this is 1/3. Now I have 3 over 9. So 3 divided by 9, I want a fraction. I don't actually have to hit enter, I can go ahead right now and go ahead and hit math, fraction, and that reduced fraction is 1/3, same thing. Then 4 over 12. So 4 divided by 12, fraction, 1/3. So I can go here and type 1/3. So, because these are similar triangles, they have proportional sides. Those corresponding sides are proportional. That means the ratio of one matching side to the other is going to be the same for all 3 sets when they're reduced. So that's one way we can tell if we have 2 similar polygons. And whenever this reduced ratio is the 1/3, that's called our scale factor. So we can say the polygons are similar with a scale factor of 1/3. That's that reduced ratio of one set of corresponding sides to the other. Now we can use some of this information to find missing side lengths in similar polygons. So you can use proportions and those scale factors, which are those reduced ratios, to find missing side lengths in similar polygons. So here's what a question like that might look like. I'll say these 2 polygons are similar, find X and Y. So here I've given you 2 polygons that again happen to be triangles, and I want you to find X and Y. The important information here is that I'm already telling you they are similar. So because I am telling you that they are for sure similar, I know that these corresponding angles are congruent, and they're already marked that way. I also know that their corresponding sides are going to be proportional. Okay, so I'm going to first write a similarity statement here just to make sure we have everything in the right order. So we have triangle. I'm going to just name the first one in any order. I'll say STR. is similar to triangle, and then it's important that I have the matching order. So S is congruent to N, so S and N are both first. T is congruent to P, so T and P go second. R is congruent to M, those angles, so R and M, those angles go last. So now I have that order. So now that I have that order, I'm going to figure out which sides match up and are proportional. So ST is first, NP is first. So I could put ST over NP. TR is next, and PM is next. So TR over PM. And then S to R, N to M. So SR, NM. So now I have those sides, and I can look on these polygons and I can see that too. ST matches with NP, that works. The second set, TR matches up with PM, and SR matches up with NM. And these are drawn very nicely where you can very clearly see what matches up. But I could have this triangle twisted all around, and it wouldn't be as easy to see. So it's very important to look at the matching angles and go ahead and try and write that similarity statement first. So now I'm going to write in the side lengths that we have. ST, we don't know, it's X. NP, we do know is 13. TR is 38. And PM is Y. SR is 32. And NM is 16. Okay, so from here there are different proportions we can set up. We can use just these two to solve, but I have two missing pieces, an X and a Y, so that won't really help us so much. I can set these two together equal and solve. That would work. I only have one variable. Or I could set these two equal and solve, and that would work because I only have one variable. So I'm going to write all of those out for you so you can see. I could choose the first two. X over 13 equals 38 over Y. But because I have two different variables, that one won't help us. I can write X over 13 equals 32 over 16. That one I can solve. I'll put an or here. Or I could write 38 over Y equals 32 over 16. And that one there I could solve. Okay, so three different possibilities, but that one's not going to work. So we're going to solve these two. This will help us find X, that'll help us find Y. Now, you can use these large numbers, and you can cross multiply with these very, very large numbers and get your answer. Or, instead of using those large numbers, you can use that scale factor that we talked about earlier. So I'll do it both ways, and I'll show you how to do each. If you choose to use these numbers, you have 16 times X, which is equal to 13 times 32. So 16 times X is 16X. This is pretty large, so I want you to check large numbers like that into your calculators. So 13 times 32 gives us 416, so big numbers. All right, 416. Then to continue solving, you divide both sides by 16. So we take that divided by 16, and I get a nice pretty 26. So X equals 26. So that's working out one problem using those original numbers that we had. Now you can also use a scale factor. So use a scale factor. Remember, a scale factor is just one of these fractions that have been simplified. So if I take 32 and I divide that by 16, I get 2. And we know 2 is the same as 2 over 1. So if you wanted to, you could change this to 2 over 1. Okay, so I'm going to put a note here. Scale factor. That's optional. If you want to do that, you can, but you do not have to do that. Here's how it helps. 38 times 1 is 38. and I should probably write that out, 38 times 1, we're doing that first. And then we have y times 2, which is just 2y. So we have a little bit smaller numbers than we had over here. Now I can divide both sides by 2. 38 divided by 2 is going to give us 19. So 19 equals y. Okay, and last, you can also use proportions and scale factors to find perimeters of similar polygons. So if triangle DEF is similar to triangle GHJ, find the scale factor of triangle DEF to triangle GHJ, which means you're going to take that ratio of one side length to the other corresponding side length and simplify it, and the perimeter of each triangle. So I can go ahead and I can sketch out two triangles here. I have D, E, F, G, H, J. Angle D and G are congruent. Angle E and H are congruent. And angle F and J are congruent. Okay. So those are some angle markings you can write in based on this scale factor based on this similarity statement to kind of help you see visually what sides might match up. I can see these two are going to be corresponding sides, these are corresponding sides, these are corresponding sides. So if I give you these lengths 10, 8, and 12, and I tell you HJ is 12. You want to find the perimeter of this triangle and this triangle of each one, and you want to find a scale factor. So let's start with scale factor first. Let's remember a scale factor is just going to be that reduced ratio of one corresponding side to the other. And I'm telling you the order to go in of triangle DEF here to triangle GHJ here. So here to here. And I want to know which one of these sides corresponds to this. Well, I can see here HJ are my last two. So HJ should match up with EF. And I can see that visually, HJ and EF, those sides do match up. So from here to here, my scale factor is 8 to 12, but I have to have it reduced. So in your calculator, 8 divided by 12, I want it as a reduced fraction, so I can hit math, fraction, and it's 2 over 3. So my scale factor is 2 over 3. And remember that we can show scale factor using that lowercase r. So that's what our scale factor is, so that's one of our answers. Now, I also want to know the perimeter of each triangle. So we kind of have to remember back, perimeter is the distance around a triangle. So if I want the perimeter of triangle DEF, I just add up all the sides. 10 plus 8 plus 12. Well, 10 plus 8 is 18. 18 plus 12 gives us 30. So 30. So that perimeter is 30 units. So that's one of them. Then I also want to know the perimeter of this triangle. But I only know one side. I can't add up the other two. But you can use proportions and scale factors to find perimeters of similar polygons as well. So what that means is our scale factor of this triangle to this triangle is equal to the perimeter of triangle DEF to the perimeter of triangle GHJ. So I can use that scale factor to find perimeters just like I can to set up those sides. So that scale factor 2 over 3 is equal to the perimeter of the first triangle which we found was 30 when we added all of those up, to the perimeter of the other triangle, GHJ. And instead of writing perimeter of triangle GHJ, I'm going to just kind of cover that up. We're just going to use P to make this a little bit shorter. Okay. So now I have this new proportion, 2 over 3 equals 30 over P. Well, that's a pretty simple proportion to solve. I'm going to cross multiply with these. So 2 times P equals 3 times 30, and then work that out. So 2 times P is 2P, 3 times 30 is 90. Divide both sides by 2, and we get P equals 45 units. So that means the perimeter of triangle GHJ is 45 units. And I'm going to write that down somewhere over here. Perimeter of triangle GHJ. Right there.